Before we start this video, a large thank you to Ken, Nate, Jake, Tim, a name I unfortunately cannot pronounce. Thank you for the support, my friend, and Peggy for their support on Patreon. I hope you guys enjoy the video. And a massive thank you to Slim Shaggy for their immense support to the channel on Patreon. You are greatly appreciated, my friend. I hope you are all having a fantastic week. Welcome back. So let's start by opening up our player camera because, as the title suggests, we're going to make a functional camera in this video. So let's make a public void for handle all camera actions, and then let's do what we normally do, and let's start making some pseudocode here and outline our goals for the video. So we have three main things we want to get done for a fully functioning camera. That is, it needs to follow the player or the target. It needs to rotate around the player or the target. And lastly, it needs to collide with the environment, and it needs to not be able to pass through walls and such. And these are really the three staples for a working camera. So let's start with follow the player. I'm going to make a private void, and I'm going to call it follow player. And again, alternatively, if you're using a camera for multiple desires, you can change this to follow target. That name might suit the functionality a bit better. So once we have that, we need to make a couple of variables to start us off. I'm going to make a header. I'm going to call this camera settings. And as it implies, this is just things you can tweak to actually change the performance of the camera and how it interacts with the game. So I'm going to make a private vector3 called camera velocity. Now this is not actually a variable we change, but rather something we use. I'll show you what I mean in just a second. And then I'm going to make a private float for camera smooth speed. And this is one we change. I'm going to initialize this at 1. And then right down here in follow target, I'm going to begin to write some code. Actually, first we also need the player manager, or our player as a reference. I don't have my namespace, so I can't use it. So I'm going to start by putting in my namespace, as is per tradition. And I'm going to call the player manager variable and just name it player. And I'm going to basically use this as a check to make sure that we have a player for this camera. And if we don't, then we're not going to do anything. I'm going to move this right here, just again, preference. So down here in the handle all camera actions, we're going to say if the player does not equal null, then go ahead and attempt to perform our three functionalities. And if it is null, then don't do anything. So the follow target, in our case, will definitely be the player. So I'm going to make a vector3 for the target camera's position, and that's going to equal a vector3.smoothDamp between the current position that the camera is at and then the player's position. So we want the camera to move from wherever it's at always towards the player. We're going to reference our camera velocity because this function requires that, and we're going to pass our smooth time times time.delta time. Except we didn't call it smooth time. That's an autofill suggestion. We called it camera smooth speed. All right, that looks fine. Wonderful. Now I'm going to make a comment here. Basically, the bigger this number is, the longer it will take your camera to move towards your character after you've moved from wherever you're at. So, for example, if you roll forward, then the smooth speed is going to basically deduce how long it takes for the camera to catch up to you. So we're going to tweak that in the future to change it depending on certain actions. We're going to say transform.position equals target camera position. So that's it. It's that simple. Now let's go to our player manager, and we need to set our player up with the camera when the game starts. So we're going to call a function override on network spawn. And this is called when this object is spawned as a network object. So when you start the network. And we're going to start by just simply saying if is owner. And in this case, since it's on the player manager and this is a player object, this means that if this player object with this player manager scripts is the local client's player object, so if it's yours or whoever is connecting to your game, if it's theirs, then we know that this is true. So if this is the case and this is the local player's object, we're going to say player camera.instance.player equals this. So we're just giving the player camera this player object. That's it. So again, if the local player connects and this is the local player's game object, then assign the camera's player variable to this variable. Very straightforward. All right, so let's go into the character manager base class. We're only doing this because we're going to make a virtual late update because all your camera functionality should be called on late update. It's just a Unity thing. And because we're going to make a late update function, we want to first make it in the base class, just in case we want to add some stuff to it later over there. And then come over to our player manager class and override late update. And we're also going to make a check here, because if you're not the owner, then you don't want to run any camera logic, because again, only one camera in the scene, it goes to the local players. So if this is not the local player, then return. And then we're going to say player camera.instance.handle all camera actions. It's just that simple. There we go. So, all right, let's jump back over to the world scene now. Make sure you delete the camera from your world scene. You should only have one camera in the world. That's the camera we make at the main menu that carries on through all of the scenes. And now let's jump back over to the player camera scripts and let's call follow player in our handle all camera actions. Otherwise, nothing will happen. And let's save that. Now, if we go into the game, you can see here, I am following the player and it's working as intended. So that's great. But you can see here we can pass through walls. I can't rotate around, so it's very incomplete right now. So let's go and drag a scene view though over, and you can see that if I highlight my player camera object, it is definitely sticking to the player. So if I click the player here, you can see the transform is the same. What I'm trying to say is that the camera is actually following the transform of the player, and that is working as intended. So let's go to the player camera and right click, and let's create a new empty game object. Let's call this camera pivot. I'm going to open some brackets. I'm just going to say up and down. And then I'm going to put in the player camera here left and right. And you might be wondering why I'm doing that. Well, I want to make it very clear that when we apply our camera rotations, okay, the camera pivot object is rotating up and down, and the main object is rotating left and right. Let's unpack that prefab so we can put the main camera as a child of the camera pivot, and then you can drag it into your prefab and click replace anyway. So basically with this setup, we're going to use one object to rotate up and down and one to rotate left and right. And now we can actually position our camera to a place where we want it here. So let's move the Z value here to set it up, because we need to back off from the player a little bit. So I'm going to put mine at -2.5. And then use the camera pivot to adjust the height of the camera on the Y value. So I'm going to put mine at 1.65, we'll try. And again, we're going to need to adjust this and drag your prefab back so it saves. Now, if we go into the game, we can actually test it out and see. So that's a bit too high for my liking. So I'm going to just come down here and change the camera pivot a little bit, lower it. You can see here, there we go. And that's where the camera is going to essentially rest. And you can back it off or move it closer with the Z value on the camera object. So this is how you're going to get your bearings for how close you want the camera to be. Okay, so that looks good. Now you can copy the component here like so, and then you can go into your prefab and paste that in there by just right clicking and clicking paste component values. I'm in my prefab, I'll go to my scene view so you can see it. So you can just do paste component values, or you can just enter the values in individually, it doesn't matter. Just make sure you're doing it to your prefab, so when you start the game, the changes apply to the object. So this is looking really cool already. We already have the viewpoint of an actual game now, but we still need to do a lot. So we need to rotate our camera now, and we need to collide with the environment. So let's jump back in now and handle the rotate around players. So we have our follow target. I'm going to rename this to handle follow target, because I'm a stickler for naming conventions, as you will learn if you haven't already. And then I'm going to make a private void for handle rotations. Okay, so as it suggests, it's going to handle rotations. Now, in the future, when we're locked on, we're going to force the rotation to rotate towards our lock target. What I'm trying to say is we're going to double back here and change some things. Obviously, as the game becomes more complex, we have to layer on more logic. So I'm going to make a comment here for the future. If we are locked on, we force our rotation towards our lock-on target, because we always want to face the thing we're locked onto. Otherwise, you rotate normally. And I'm going to take a sip of tea. Okay, so let's go now to the camera velocity. I'm just going to move that down here, because I'm going to make another header called camera values. Okay. So you can make a comment here if you want. Like, I'm going to comment on the camera settings. We can change these settings to actually impact how the camera interacts with the world, or we can say we can tweak the camera performance. And these down here are just a reflection of some of the things that the camera is doing. So you can say just displays camera values, but I'm not going to leave a comment here because, again, I think the name in this case is very, very descriptive of what this actually is. So I'm going to make a few more variables here now. The first one is going to be a serializable field, so you can see it in the inspector should you need to. I'm going to call it, or it's going to be uptype float. I'm going to call it left and right look angle. Okay, and I'm going to make a serializable field for the float up and down look angle. So remember when we called our parent object left and right and our pivot up and down? Well, this is going to be the angle that they're rotating on for their respective axes. So I'm then going to go to the camera settings. I'm going to make an up and down rotation speed. I'm going to initialize mine at about 220. And then I'm going to make a left and right rotation speed. So you can just have one general rotation speed if you would like, but a lot of games actually have different rotation speeds for different axes, meaning you can go faster on one axis than the other. Typically, you can look faster on the left and right axes. But I'm going to keep mine the same right now because this is this feels nice to me when I was doing some testing earlier. So, but tweak these as you see fit. Everyone's will probably be a little bit different depending on what kind of vibe you're going for. So I'm then going to make a serializable field for my minimum pivot and my maximum pivot, okay? And this is the lowest point you can look down and the highest point you can look up. We do this so you can't circle the camera around yourself while looking up and down, just making you feel nauseous. So I'm going to initialize my minimum at -30. Again, tweak this to your heart's content. It will be different for everybody. And my maximum is going to be 60. All right, so the lowest angle we can look down, I'm just going to make a comment so this is very clear. The lowest point you are able to look down, and this will be the highest point you're able to look up. So the lowest point for me will be -30, and the highest point will be +60, okay? All right, so let's press on now that we have our variables. Let's start writing some logic here for the rotations. And let's take this one step at a time. We're gonna break this down to make it super simple. All right, so normal rotations first, because that's all we're going to do in this video because we don't have a lock-on system yet. So our left and right look angle is equal to what? Well, it's times equal to our, think back to our player's movement here, our player input manager dot instance, and then we want to get our horizontal camera movement. And we don't have a movement input for that yet, so we got to go make one. We have our left joystick for our character's movement, and much like our left joystick, our right joystick is going to handle the camera's movement, and it's going to work pretty much identical. So let's make a new action map. I'm going to call mine player camera. The other one's called player movement. I'm going to call this new action camera controls. And then just like before, let's set it to a pass-through. It needs to be a vector 2 because there's up and down and left and right and the analog stick. And we want to delete that and we want to add a new up, down, left, and right composite, okay? And again, this is just like before. I'm going to call this right stick because it is going to be the right stick on the controller for me. If you want to use a mouse, you can use a mouse too. And then I'm going to change it to an analog instead of a digital. And then I'm going to put in my values here. So for example, you know this by now, up will be on the gamepad, right stick up, then right stick down, then right stick left, and right stick right. If you're going to use the mouse, you need to use a thing called mouse delta. So if you don't know how to do that, a quick Google search will tell you how. If you're still confused, leave a comment below. If you want me to set it up in the next video, I'll just do it quickly in the first like 30 seconds because it is super straightforward. I'm going to save that and close it out. And then I'm going to open this up here now, and I'm going to go over to the movement input on the input manager again. I'm going to paste it, and I'm going to change it from movement input to camera input. So this is going to work, as I said, identical to the movement input. So we can just copy a lot of this over and reuse it. So copy the player controls, player movement.movement, and paste it. I'm going to change it to player controls.player.camera.controls.performed. And instead of assigning it to our movement input, we're going to assign it to our camera input. So you can see here now the joysticks just work. And I'm going to change the name actually to camera controls. I'm going to change it to camera or just movement, sorry. I'm going to save that so it looks very similar to our player movement. So it'll be player controls.playerCamera.movement.performed plus equals I equals greater than camera input, okay? So again, identical, just taking the inputs of our joysticks like the last video that we did, and we're assigning it to this vector 2 called camera input. Now, just like our movement input, we got to break them down into two values. So copy and paste your vertical and horizontal input and make a camera version of them because we need to know what the values are on each axis so we can apply the rotation on each axis accordingly based on those values, okay? So I'm gonna just, my goodness, I can't copy this. I'm gonna move this down right here and just paste this so it's kind of separated from the player's movement. And I'm gonna just make a header here called movement input. and a header down here called camera movement input. Alternatively, you could say camera rotation input. Honestly, whatever, as long as you know what this means. Make it something that's going to be clear to you, so you look back on this and there's no confusion if you return to the code 6 months from now. Okay, so I am going to save that, and right below handle movement input, I'm going to make a private void called handle camera movement input. And likewise, we can open up our handle movement input. I'm going to rename that to handle player movement input. And we can just basically copy what's inside here for the first couple of lines and just replace the vertical input with camera vertical input, and the horizontal input with camera horizontal input, and then the movement input with the camera input. So again, for those of you who might forget, we're just taking the values of our joystick on the axes of up and down and left and right, and we're assigning it to our camera's vector 2, and then we're taking those values of up, down, left, and right and assigning them to 2 separate floats. Very straightforward. Lastly, we need to call it on the update function here. So right below handle player movement input, I'm going to say handle camera movement input. And now I am going to go over to our player camera again, save that, and now we can start writing some code. So left and right look angle is equal to, plus equal to, our player input manager.instance, because it's a singleton, dot camera horizontal input times our left and right look speed. Look familiar to you? It's very similar to player movement. And then we're going to say times time dot delta time. Okay, so right below that, that's our left and right sorted. Our up and down look angle is going to be minus equals to the player input manager dot instance dot camera vertical input times up and down rotation speed times time dot delta time. Now we need to do something else for this one because we need to clamp it. So right after this, again, it's identical to the left and right, except it's up and down. We need to clamp this to make sure it's never exceeding our maximum or going anything beneath our minimum. So to do that, we just simply say up and down look angle is equal to mathf.clamp. And to clamp it, we pass what it is right now, and then we pass the minimum and maximum allowances for it. So basically, if this look angle goes below the minimum or above the maximum, it will clamp it to either the minimum or maximum, whatever is closest to. Okay? So I'm going to make a comment here, rotate left and right based on the horizontal movement of the camera inputs. So for me, it's the right joystick. And then I'm going to make another comment saying, I need to tab this so it's spaced, rotate up and down based on the vertical movement of the right joystick. So it is just that simple. When you break it down to its smaller steps, one thing at a time, making a camera is not that complicated. A lot of people are intimidated by it, and that's okay. So then we can say clamp the up and down look angle between a minimum and maximum value. All right, that is looking good. Now we're not done. We haven't applied any of these values yet, so let's do that right now. We're going to make a vector 3 for the camera's rotation. It's going to be equal to vector3.0 at first. And then we're going to say camera rotation.y is equal to our left and right look angle. And I know it's confusing because y usually means up and down, but in terms of rotation, it is left and right. Okay, so then we're going to say quaternion target rotation is equal to quaternion.Euler, and we're going to pass the camera rotation, just like that. So then we're going to say transform.rotation is equal to target rotation. So this rotates this game object, okay? Rotate this game object on the y-axis, which is left and right. So as I said before, the main game object will handle the left and right rotations. Now we have a pivot object too, which handles the up and down rotation. So now let's do that. Again, one thing at a time. Camera rotation is equal to vector3.0, so we're going to reset it. And then we're going to say camera rotation.x is equal to up and down look angle. So again, the x being the up and down rotation. And then we're going to say target rotation is equal to quaternion.Euler, camera rotation, and then camera pivot transform dot local rotation is equal to camera rotation, or sorry, our target rotation. So we don't have a game object or a variable for this yet, but I'm also going to move this so it's a little bit more neat. So watch this. You can, basically this variable is being assigned here, but it's being reused below. So I'm just going to assign it above, so it's kind of separate. And then I'm just going to also move this really quick, copy it, and assign this up here as well. And then I'm just going to delete this. So you can see here, we're just basically reusing these two variables for the left and right, and then the up and down. And I'm going to make a comment here so it's very clear. Rotate this game object up and down, this game object being the pivot game object. And there we go. You can see that we're just taking the main object, rotating it left and right, and then taking the pivot and rotating it up and down. So let's make a variable for the camera's pivot object. So this is going to be serializable field transform. I'm going to call this camera pivot transform. Call this anything you want as long as it's very indicative of the fact that it is the pivot game object on the camera. So you can see here I have mine called camera pivot. So again, the camera pivot up and down and the main camera object left and right. And the actual camera object itself does not move at all. So this main parent game object left and right, pivot up and down, main camera does not move. Okay, so we come down here now and that is looking all good. So let's save it, and I'm just going to, again, keep these up here because I find it's neater. You can see they're just called down here, or they're changed rather, but if we declare them up here, it just looks neater to me and it's easier to read. So I hope that is very clear. Save that. Now, if I go into the game and start the game, you can see I can move around, and look at that. I can rotate my camera around my character, and I gotta say, it feels pretty great. So we have a minimum maximum to the up and down, so we can't look beyond that, but we can still go through the wall here. So let's do camera collisions next. This is an area that a lot of people also trip up in, but I promise you it's pretty simple. We'll take it one step at a time. Let's make a private void for handle collisions, and there's a bunch of ways you can do this, dozens literally. So we're going to do it the way I do it in Nephilim. It's pretty straightforward. We just need one variable for the camera's collision itself, which is the camera collision radius. And we need a couple more variables for where we're going to move the camera in the event of a collision, but this main variable, I'm going to call it camera collision offset. 0.2f I find is a pretty good value. Tweak this to whatever you want. So if it's larger, you're going to be colliding with stuff further away. If it's tiny, you can get really close to it before you collide with it. So I'm going to make a private float for default camera position, and a private float for the target camera position. Okay, and this will become very clear very shortly. I'm just going to say that value used for the camera's collision, and in a minute we're going to come back to this and further explain it. But to explain it first, I need to start writing some code so it's much more clear. And I'm going to take a sip of tea. Okay, so down here in the handle collisions, we're going to start by saying the target camera position is equal to default camera position. And now we're going to make a raycast hit called hit. And this is just a thing that tracks raycast data if you use a raycast and it touches something. And then we're going to establish the direction we want to fire our raycast in. So the direction is going to be the camera object dot transform dot position minus the camera's pivot dot transform dot position. So again, this is just equates to a direction that we're going to fire our raycast in to check for collisions, okay? And then we're going to say the direction normalize. So just normalize the direction that you have. And then we are going to say if physics dot, and I'm going to use a sphere cast here. I find it's perfect for this situation. If physics dot sphere cast, and then we're going to pass our camera pivot transform dot position, comma, and we're going to use for the radius our camera collision offset. And I guess we can rename this actually to, if you want to, camera collision radius. That's probably a better name because that is what it is. It's the radius of the camera before it collides with something. It's also the radius of the sphere cast, so it lines up perfectly. So I'm going to rename that to camera collision radius. And then we can use a comma for the direction we want to shoot it in. And we got our direction above. And then we can pass our out hit to collect data if it touches anything. And then we can say mathf.abs, and we can pass our target camera position for the distance. And then for our layer mask, we can say 0 for now because that's a default layer, but we're going to come back to that and change that in a bit. We're actually going to give it a set of layers it can collide with instead of just one. And I'm going to take a sip of tea. All right, so this is 0, just to be clear. See this? Default layer in the game is 0, but we are going to change that in a sec. So that's actually not going to work with the way it's set up right now. Don't worry about it, though. So the default camera position, we don't actually assign this. Well, what is this? Let's explain. the default camera position is going to be where it sits on the z-axis, so the forward and backwards. And if your camera gets nudged, we want to move it forward or backward. That's how it's going to work with collisions. So default camera position is equal to camera object, the object of the actual camera, dot transform dot local position dot z. And now that we have that established, let's actually rename that to camera z position, so it's very, very obvious. Again, z position is forward and backwards. And then let's change the target camera position to target camera z position. So if this camera touches something, we want to move it forward or backward on the z axis if it collides. So if you hit a wall, you push it backwards. You get what I'm saying? So you can see here z is forward and backward. Now inside the if physics.spherecast, we want to get a distance, and the distance is going to be the distance from the object that we're colliding with. And how do we get this? Well, we have our hit variable that we're passing, so that gives us some data of what we hit. So we can say the distance from hit object is equal to vector3.distance, and we're going to pass our camera pivot transform.position by the hit.points. So it's the object that we're actually hitting with the spherecast. Okay. And then we're going to say target camera position is going to be equal to minus dot direction or distance from hit object minus the camera collision radius. All right, now right below that, we're going to say if mathf.abs, so it's an absolute value, no negative signs here. If the target camera position is less than the camera collision radius, then we are just simply going to say the target camera position, the z position, equals minus camera collision radius. So we're just subtracting the camera collision radius. And then lastly, we're going to come down here and say camera, and I have to make an actual vector3 variable for our camera's object position, because this is how we're going to move the actual camera object on the z-axis. So let's go up here and make a vector3 for that. Right down here will be under camera values, because this isn't something you're actually changing to change the performance of the camera. This is just a reflection of something that's being done by the camera. So camera object position, I'm going to make a comment saying use for camera collisions, and I'm going to take a sip of tea. And we're going to say moves the camera object to this position. And this is upon colliding with another object. So let's go down here and say camera object position dot z, because again we're only moving it forward and backward if it touches something, is equal to a mathf.lerp between our camera's current position on the z-axis, so that's camera object.transform dot local position, that's important, dot z, you have to use local position here, not world position. And then we're going to pass it by the target camera z position, and then our camera collision radius is not our time. I'm just going to say for our time 0.2f, although you could use that, but it's that you shouldn't just actually assign a time variable if you want to. And then we're going to say camera object.transform.local position is equal to camera object position. So this might be a little bit confusing. People haven't done collisions before, but it is pretty straightforward. Basically, we're checking if there's an object in front of us, and if we're touching something within this camera's collision radius, then we're pushing the camera back, so we're not going through it. That's all it does, really, to oversimplify it. Let's make a serializable field for a layer mask, and we're going to call this collide with layers. Now, anything that we enable on this layer mask, now we pass it here where the 0 is, we just pass the collide with layers. Anything that we enable on this layer mask, the camera will collide with, and when it touches it, it will push backwards from it. So let's drag in our prefab to save it, go into the game. You can see now you're going to have to tweak your height values again and your forward values, because we've changed some stuff in the code, and now the camera changes accordingly. So I'm going to adjust the Y value on my pivot to 1.3, between 1.5 1.3. Again, whatever you want, play around with this. It might differ heavily depending on how close your camera is, the size of your character model, yada, yada, yada. So when you have that to a point where you like it, let's go back into the game here now and press play, new game, and now I'm going to move. You can see the camera rotates fine. I'm locked at a maximum height and a maximum look down value, so that's working as intended. We rotate fine, and now if I go up to this wall and I rotate towards it, you can see the camera will actually glide off of the wall, and that is because all of these cubes are set to a layer of default, and the camera collides with the default layer. There you go, guys. Setting up a camera is really not that hard, and I like doing it this way. Plus, now that you know the code, let's go back and comment this too so it's clear. So I'm going to say we check if there is an object in front of our camera. I'm going to take a sip of tea. Okay, so we check if there's an object in front of our camera of our from our desired direction. So the desired direction is up here. This is the direction we're actually firing the sphere cast to check. And if there is something in front of the camera, then we just do some math to see how close or how far away it is. And then if the object is too close, we're basically just backing our camera off, and we're assigning the camera's new Z position using a mathf lerp over time, so it's not so rigid and bumpy, and it should do it in a very smooth manner. And it's just basically snapping your camera off of anything that it touches within these collided with layers. Now, some people always ask me, and I get this question a lot, especially in the Dark Souls series, why don't you use Sign Machine? And I'm going to give you an answer in this video. There's nothing wrong with using Sign Machine. Use it if you're comfortable with it. The reason why I don't use Sign Machine is of two major reasons. One, the first one is this is a tutorial series, and I like to show you as much as I can how to do things on your own from the ground up. But the biggest reason is that I don't know the code within Sign Machine, meaning I'm not familiar with the inner workings of it. So when I add things that are camera dependent in the future, I've written this camera functionality on my own. And because of that, I know where everything is, and I know how to change anything to suit my needs. And there is nothing in this camera except for the things that I need. And because of that, I find it much easier to work with, and I just like it that way. But if you're a person who likes to use tools like that to save some time, that is perfectly fine. Go ahead and do it, as long as you know how to edit the code to suit your needs when we add on more things in the future. All right, guys, thank you so much for tuning in. I hope this video was of use to you, and I hope you learned something. And if you would like to leave a comment and a like, it does genuinely help out the series so much, and I would greatly appreciate you. Also, a special thank you to my patrons. It is because of you lovely people I get to keep doing this, and I love doing this. Very excited to bring you guys the next episode, where we're going to handle animating our character and animating our character on a network, so that if we basically play any locomotion animations locally, we do it on the network, and both characters will animate for each other, so you won't just see a man T-posing and sliding around, as fun as that is. Alright guys, I'll see you in the next one.